Hi everyone, today we're going to be talking about finding inverse functions. So inverse functions have this relationship to the original function where they're flipped over the line y equals f. So here I have my original function in purple, and the inverse f negative 1 of x is flipped over this line y equals x. So it has that symmetry about it right there. And what we're going to do today is figure out if we're given a simple function like negative x plus 4, how do we find what the inverse is? And how we do that is order of operations backwards. So you have, please excuse my dear Aunt Sally, PEMDAS. Normally we do everything in parentheses first and work our way back to subtraction and addition. Well, when finding inverses, you're going to start with adding and subtracting and working your way back to the parentheses. So what we're going to do is start with what the core of our function is, which is always an x. X is always at the heart of our function. And we're going to do everything backwards. So, if we look at PEMDAS, adding and subtraction come last, so they're going to come first now. So I see add 4 in the original function, which means I'm going to subtract 4 in the inverse function. Then I also see a multiply by negative 1, so I'm going to divide everything by negative 1. And that is the inverse function. So f of negative 1 of x equals this thing. And if we simplify that down, if we divide everything by a negative, it just changes the signs. So we have negative x plus 4. Notice that's the same function we started with. So how can that be? Well, if I draw a graph of what this actually looks like, I have a y-intercept of 4, and I also have an x-intercept of 4 for the original function. So when I draw that in, kind of wobbly right there, that is my function. That is also my inverse function, because if I draw in my line of symmetry y equals x, this dotted line in red, you can see if I flip it over, it's going to land right on itself. The graph is going to land right on top of itself, right here. So the original function is the inverse of that function. Okay? So let's keep on working with these. So we're going to undo PEMDAS, starting with adding and subtracting. So put your x down. That's the heart of everything. Then see if there's any addition and subtraction, and do the opposite. So we're going to subtract 3 over 2. Then we see multiply by 1/2, so we're going to divide by 1/2. Or you can multiply by the reciprocal. The reciprocal of 1 over 2 is 2. So g prime, g to the negative 1, had a little bit of calculus in there, g inverse equals 2x minus 3/2. And simplifying that down, we have 2x minus 3. That is the inverse function. Okay? Why don't you try the next two on your own, see if you can do those. Alright, so we want to find h inverse of x. So everything starts with x, so I'm going to put that down first. And we have to do everything backwards. Well, is there addition and subtraction? Yes, there is, but we can't touch that yet because it's in parentheses. So we have to work our way back down the line. Multiplication and division, well, we see a divide by 2, so we're going to multiply x by 2. And now we can get inside the parentheses. We have no exponents, so now we look back into the parentheses. Once you're in the parentheses, you have to start PEMDAS over. So look and see if there's any addition and subtraction. We see that we're adding 18, so here we're going to subtract 18. And then we see a multiply by 5, so that means we're going to divide by 5. And that's all you really have to do for that inverse. You could simplify it if you would like to, but sometimes fractions aren't any better than what we're looking at right now as this whole quantity over 5. Okay? The next one, f of x, we want to find f inverse of x. So looking at that, we see parentheses right away. Parentheses are at the end, so we can't touch anything inside there until we do all this other stuff. So is there any addition and subtraction outside? No. Is there any multiplication and division outside the parentheses? Yeah, there is. There's a multiply by 2 right there. So I'm going to start with my x, and I'm going to divide by 2. Do the opposite. And now I'm inside the parentheses. But when I get inside the parentheses, everything's being divided by 4. So that's like another parentheses inside of here. That means you have to go through PEMDAS backwards. So there is no addition and subtraction inside this blob until you get to the numerator, but there is multiplication and division. We're dividing by 4. So we're going to do the opposite and multiply by 4. So we took care of the 2, we took care of the 4. Now we're finally inside this parentheses part. Now we can do PEMDAS backwards again. So adding and subtracting, I have a plus 7, so I'm going to minus 7, and now that one's taken care of. I'm down to x, so that's all I have to do. So F inverse of x is equal to 4 times this quantity, x over 2, minus 7. If you want to simplify that a little bit, you could say this 4 and this 2 reduce, so it's just 2x, and then we have a minus 7 at the end. Okay? So that is the inverse function. Now sometimes that's hard for people to think about, just to undo PEMDAS backwards. And some people find it very, very easy. The other way to think about how to find an inverse is to think about what's actually happening. If we look at our function here, we have maybe, this is the point 0, 2. So over 0, up 2. The inverse reflects it over the line y equals x. So the corresponding point on the inverse function is going to be 2, 0. The x and the y switch. These points switch for us from the original to the inverse. So what we can do when dealing with functions and finding their inverses is we can switch the x and y values and solve for x, because the x and y values switched here. So I'm going to rewrite this function. Instead of g of x, I'm going to write y equals. I'm going to write y equals negative 3x plus 7. In my next step, I'm going to switch the x and the y. So I'm going to write x equals minus negative 3 times y plus 7. So the x and the y switched. And now, just solve for y. So what does y equal? Well, I'm going to subtract the 7 over, and I'm going to divide by negative 3. So I'm going to have x minus 7 divided by negative 3. That is equal to y. So our inverse function, g of negative 1 of x equals x minus 7 over negative 3. So that is our inverse function. So all we're doing is switching the x and the y, and then solve for y. All right, let's try the next one together as well. So we have h of x equals 3/4 x plus 5/2. So I'm going to write y equals 3/4 x plus 5/2. I'm going to switch the x and the y around, and then I'm going to solve. So I would subtract the 5/2 over and then multiply by 4/3, the reciprocal of that. So I'm going to move this up here. So I am going to have x minus 5/2, and I'm going to multiply by the reciprocal of that, which is 4/3, and that is equal to now y. If you want, you can distribute things through. So we have h inverse of x equals 4/3 x minus this 4 and 2 reduce, so I'm really multiplying by 5 by 2/3, so this is really 10 over 3. So here's the inverse function, switching the x and the y's. Alright, why don't you try the next two on your own, pause the video, and then resume it, and we'll go over the answers. Alright. So here I'm just going to switch right away. So this is x equals 6y minus 14 over 3. Solve for y. So I'm going to multiply the 3 to the other side, so I have 3x equals 6y minus 14. Move this up there. I'm now going to add the 14 over and divide by 6. So 3x plus 14 divided by 6 equals y. So f inverse x equals 3x plus 14 over 6. Again, if you want, you can break this down into two separate fractions and reduce then. So this would become 1/2 x plus 7 over 3 if you wanted to. Alright, let's try the last one. So switching x and y right away, we have x equals 1/4 2 minus y over negative 3. So I'm going to multiply by 4, so we have 4x equals 2 minus y over negative 3. Then there's also another division going on here, like another fraction. So I'm going to multiply by negative 3 to both sides, so I have negative 12 now, x equals 2 minus y. I can now subtract the 2 over, which is one way to do it. There's another way to do it. So subtract the 2 over, then you have negative y, and then divide by everything by negative 1 to get y by itself, so we have 12x plus 2 equals y. So the inverse of g is equal to 12x plus 2. Now the other way you could have done it from right here, you could have added the y over, so I'm going to do this over here. The other way you could have done it, you could have had negative 12x plus y equals 2, and then you would subtract the add the 12x over, so you have y equals 2 plus 12x. So that was the other way to do it. So whatever way works for you, if you can just think about it, oh, I'm undoing everything, I'm doing PEMDAS backwards, just go ahead and do that. Start with your x and undo everything. Or if you feel better about, oh, I know with the graph I'm switching the x and the y values, so I'm going to switch the x and the y's here and solve. If you want to do that, that's also fine. So that is how you find inverse functions.